So today we're going to look at lesson 5-4, polynomial long division and synthetic division. This can be a whole lot of gobbledygook. So the only thing I really want you to know about this first top part is just look at the following example. You need to know what's the divisor, the quotient, the dividend, and the remainder. So I'm going to just go through a real simple quick problem here. Here's the example. What if I had 23 divided by 5? So when we divide with long division, here's your division bar. The first number that we come to goes in here, and the second number goes on the outside. So you could also have written this as 23 over 5. So same thing, the top number gets parked in the garage, and the second number gets parked outside. So I'm going to put my 23 on the inside and my 5 on the outside. So before we start, this right here is your dividend. This right here is your divisor. And then we're going to get an answer, which is our quotient, and a remainder. All right, so let's go ahead and go through this. So 5, get a different color in here. So 5 does not go into 2, but 5 goes into 23 at most without going over 4 times. And then you're going to multiply 5 times 4, which is 20. And then we are going to draw our line and change our sign because we're going to subtract. That was Miss Sally dropping her broomstick. In case you're wondering. Sounded like a gunshot. Whoops. And so then you've got to subtract 23 minus 20 gives us a remainder of 3. So the other parts to this division problem, this is going to be our quotient. That's our answer to the division problem. And this right here is our remainder. Remember when you were in 3rd grade, you actually just put an R3 next to the 4. And then when you got to be a bigger person, you learned how to put a decimal and then some zeros, and you brought those down and you kept dividing out until you got a decimal. Well, we're going to pretend like we don't know how to do that we only do quotients and remainders. That's it. So then I'm going to show you how to do what's called synthetic division today. But there are some important things regarding synthetic division that I think that you should know, and so we're going to underline those. So the process for dividing a polynomial by a linear expression, so I'm going to show you what that looks like. But what's important is it must be in standard form, so that's important. And you're going to omit all variables and exponents. But I will show you what that looks like when we get there. Then we're going to use this thing called the remainder theorem. So the remainder theorem is really handy because this remainder here, I can actually use polynomial long division to evaluate an expression. And so we will use this remainder theorem to kind of show you that could be another check. So I'm not going to show you right now, but it'll all make sense in a moment. So let's review long division one more time before we actually do the polynomial long division. So here's a more complicated example. So here's my division bar, and then because this comes first, it's going to go underneath, and the 16 is going to go outside. So I have 496 on the inside and 16 on the outside. What I want you to pay attention to is the process that I'm going to use. So I'm going to take the 16 and see, does it go into 4? No. So I don't put anything up here. But the 16 does go into 49. And at most, 16 goes into 49 3 times without going over. So I'm going to put a 3 up here. Whatever I put up here has to get multiplied to everything that's down here. So I'm going to take the 3 and multiply it to the 16. The reason why we're going over this is because the procedure for polynomial long division is nearly identical to the procedure for regular long division. So whatever's up here, you're going to multiply out to here, and 16 times 3 is 48. Then, this is my favorite little ditty. We are going to, I'm going to get a better looking green. We're going to draw our line and change our sign because I don't like to add, or I don't like to subtract, I like to add. And then technically I'm going to add down. 49 and a negative 48 is 1. I have a 1. Then we're going to bring down the 6. And we start the whole process all over again. I want to look at the 16 and how many times does 16 divide into 16 at most. And in this case, it goes in there 1 time. And then I have to multiply this 1 to everything here. So 1 times 16 is 16. Then I'm going to draw my line and change my sign. And then I'm going to add down. Well, those are going to cancel. And I'm going to be left with 0 for my remainder. So what's nice to know is once you get 0 as a remainder, that tells you something. That tells you that 16 must be a factor of 496. When we did the problem at the very beginning here, when we divided 23 by 5 and we got a remainder, that means that 5 is not a factor of 23 because I got a remainder. So if you get a remainder of 0, then what that means is what you divided by must be a factor of what's underneath. So 16 times 31 is 496. Okay, so how does this apply to polynomial long division? So there's several rules that you do have to learn. Rule number 1, this needs to be in standard form, or really what I mean is highest degree term to lowest degree term. And so it is high to low. And in addition to that, you can't miss any terms in between your bookends. So these are your bookends. If there's anything missing in here, you have to put in a placeholder with a 0 as a coefficient. So in other words, if I was missing this x term, and I just had 4x squared plus 6, and I was missing this x term, I would have put in a plus 0x. And you will see that happen, but that's one of the rules. So let's go ahead and use our division bar. And just as with regular long division, whatever comes first here goes underneath the bar, and whatever comes second is going to go out here. So 4x squared plus 9x plus our 6 goes underneath, and then the x plus 6 goes outside. Then here's the part that's a little bit different. So the first thing that we're going to do is I'm going to take just the first term here and just the first term here, because unlike regular division, I actually have several terms here. You can actually divide by a trinomial, a polynomial. You can divide anything out here to anything here. It may or may not work, but typically you're going to have a monomial or a binomial here, typically. Not always. So take the first term here and the first term here, and then off to the side or in your head, I want you to divide what's underneath the radical with what is outside first terms only. So because 4x squared divided by x is 4x, I'm going to put a 4x up here. Then just like with long division, whatever's up here, we're going to multiply to everything out here, including the 6. So I'm going to multiply the 4x to the x and the 4x to the 6. So I'm going to essentially distribute 4x to the x and the 6. And it's going to be written down here. You will know if you forgot to put a placeholder here because your like terms won't line up. So if you don't have like terms that line up, you did something wrong. Go back and check it. See, did you put it in the wrong order? Did you forget a placeholder? What? So 4x times x is 4x squared. 100% of the time, these first two terms should match. Sign for sign, number for number, variable for variable. Then 4x times 6 is a positive 24x. Focus on your signs. Then this is my favorite little ditty. We're going to draw our line and change all of our signs. Every sign here got changed. 100% of the time, the first two terms should cancel. Then you're just going to add down. A 9 and a negative 24 is a negative 16. Or I'm sorry, negative 15. What was I thinking? Negative 15x. But we're not done because I can drop down this 6. So bring down the 6 plus 6. And then the whole thing starts all over again. So just like before, I'm going to take the first term here and divide it by this first term here. So off to the side, I'm going to take negative 15x, make sure you focus on your signs, and divide it by x. That's going to give me a negative 15. So the negative 15 goes up top. Whatever I put up here gets multiplied to everything here. So negative 15 times x is a negative 15x. See how they match exactly? Negative 15 times positive 6 is a positive 90. Sorry, negative 90. I'm having issues this afternoon. Positive times a negative is a negative. Now, my favorite ditty, draw your line and change all your signs. 100% of the time, the first term is going to cancel. And then you're just going to add down. So a 6 and a 96 gives you 96. And then there's nothing left to bring down. So this is your remainder. This is your quotient. This is your divisor. This is your dividend. Because we have a remainder, that tells me that x plus 6 is not a factor of this polynomial. So then your answer would be, and you have to pay attention to how they asked the question. They wanted you to divide. So the answer to your division problem is 4x minus 15. If they had said, now we can use polynomial long division to help us factor a polynomial. So I might say use polynomial long division to factor this polynomial, and one of the factors is this. If that's the case, if I get a remainder, then I would respond that no, x plus 6 is not a factor, and I'd be done. If my remainder was 0, then I could conclude that yes, this is a factor, and then I would be able to factor this further possibly or not. I don't know. Now, I'm actually not done. I totally lied. This is not my actual final answer. My bad, I forgot something. So this remainder has to get attached to this. So don't forget, what did we do with the remainder in long division? Well, you used to put just like a R96 here. But we are going to add or subtract that remainder up here. And we're going to take this remainder and put it over what we divided by. And that's technically what you do in regular long division anyway. When you're finding a decimal, you just didn't realize it. So because this is a positive 96, here's what my answer is going to look like. 4x minus 15. Then because I had a positive 96, I'm going to put a plus 96, and I'm going to put it over what I divided by. So it looks weird, but this is my answer. That whole thing is my quotient, because the remainder is part of our quotient, to be honest. So if you really want to fix this problem up here, our actual answer to this one would have been, we would have taken this 3 and put it up here as plus a 3 over 5. So 4 plus 3/5. Try it, it works. All right, so we're done with this page. So now we have a little bit change in directions. It says, use polynomial long division to divide this by this. What is the quotient and remainder? So we're just kind of dividing. They just wrote it a little bit differently. I'm going to make this just a smidge bit bigger. And here we go. If you want to, pause the video and try this on your own. If you're still unsure, then here we go. Oh, wait a minute. Am I missing any terms? X squared, x to the first, 0. So 2, 1, 0. Nope, I'm not missing anything. So we're good to go. So pause the video if you want to. So then I'm going to put the x minus 7 out in front. Then I'm going to focus on the first terms only. Here and here, I'm going to take 3x squared and divide it by x. That gives me 3x. So I know that x minus 7 goes in here 3x times. So I'm going to take this 3x and multiply it to everything here. So 3x times x is 3x squared. 100% of the time, those first terms should match, and they do. 3x times negative 7 is negative 20. Whoa, wrong one. All right, so try that again. Negative 21x. Draw your line and change all of your signs, both of them. 100% of the time, those should cancel. And then we're going to add down. Negative 29, positive 21 gives you a negative 8x. Bring down the positive 56. And then it starts all over again. I'm going to focus on the first terms only, so the negative 8x is going to get divided by this x here. So I get just a negative 8. Put it above. Negative 8 is going to multiply to everything out here. So negative 8 times x, negative 8x, negative 8 times negative 7, positive 56. Less in your head, more on paper, kill a tree. So don't forget, draw your line, change all your signs. In this case, both terms cancel out, and you are left with a remainder of 0. So what does this tell you? You should have already been alerted to the fact that it says use long division to divide. Well, I guess it didn't say to factor, so I guess you wouldn't have been alerted to that fact. But the fact that your remainder is 0 means that x minus 7 is a factor of this, and that if I took this times this, it would give me this. If we used our swing multiplication and factored that way, you should get x minus 7 times 3x minus 8, but they asked you to determine what is the quotient and remainder. So your quotient, just the quotient, so the quotient is 3x minus 8, and your remainder is 0. So this is the answer that they are looking for. Okay, so then I'm going to make this a whole lot bigger. So then this has a change in directions. It's asking you, is this a factor of this? So we can use polynomial long division to determine if something's a factor, because if I take this and divide it by x minus 2 and I get a remainder of 0, then this is a factor of this. If I get anything other than 0, it's not. So really it's a yes-no kind of question, but you have to have work to support it. So the first question I want to ask myself, am I missing any terms here? And I sure are. I'm going from 3 to 0. So I'm missing the x squared term, and I'm missing the x term. So I have to add those in. And I'm going to put the x minus 2 on the outside. Now you would have hopefully caught yourself, because when we do this division, if like terms don't line up, something's wrong. So let's focus on first terms. So the x cubed and the x. So off to the side, x cubed divided by x is x squared. So an x squared goes up top. Take this and multiply it all the way through. X squared times x is x cubed. See how they match? X squared times negative 2 is negative 2x squared. So then you want to draw your line and change all your signs. And 100% of the time that should cancel out. Then you're going to add down, and you get a positive 2x squared. Bring down your next term. Now, notice that my like term here lined up with this like term. If I had not put these placeholders here, I would have had the negative 9 over here, and negative 9 does not line up with a 2x squared. I can't add those down. So if that happens to you, you have to know that you did something wrong. So the process starts all over again. Focus on your first terms, x, the 2x squared and the x. So 2x squared divided by x is 2x. So put a 2x here. Don't forget your sign. I'm going to take this 2x and multiply it all the way through. So 2x times x is 2x squared. 2x times negative 2 is negative 4x. Draw your line, change all of your signs, and 100% of the time the first two should cancel out. Then add down. You're going to get positive 4x, bring down the negative 9, and the process starts all over again. Focus on your first terms. So the 4x divided by the x is equal to 4. So I get a plus 4 up top. Take this 4, multiply it all the way through. So 4 times x is, I'm trying to figure out what color I'm going to use. So 4 times x is positive 4x. They should match, which they do. 4 times negative 2 is negative 8. Draw your line and change all your signs. The first two cancel, add down. Negative 9 and positive 8 is a negative 1. We have a remainder. What does that tell you? Since we have a remainder, therefore, x minus 2 is not a factor. And you can stop. That's your answer. So what I would like you to do is stop the video, do number 5, make sure that you look for any missing terms, if at all, do your long division, restart the video. You're trying to determine, oh, and also your answer is written a little differently because look at what they're asking for. If it is a factor, write the function, this is your function, p is just the division of it, but you're to write this function here as a product of two factors. So over here, remember, this times this should equal this. Well, if we had a remainder, we would have put minus 1 over x minus 2, but they didn't ask for that. So your answer here is going to look a little bit different if you do have a factor. All right, so pause the video and go for it. Okay, so the first thing I'm going to do is set up my problem. I am not missing any terms. And then outside, I've got an x minus 4. My first terms are these two. So off to the side, 5x squared divided by x is 5x. So a 5x goes up top. Take the 5x and multiply it all the way through. So I get a 5x squared minus 20x. Draw your line, change your signs all the way through. The first term should cancel. Add down. If I add down, I get a positive 3x. Bring down the minus 12. Whole process starts all over again. Focus on your first terms. 3x divided by x is 3. So put a plus 3 here, and then multiply this 3 all the way through. 3 times x is 3x. 3 times negative 4 is negative 12. Don't forget to draw your line and change all your signs, and lo and behold, everything cancels and you have no remainder. So since you have no remainder, yes, x minus 4 is a factor of the polynomial. So yes, it's a factor. So this is part of your answer. The other part of your answer is it says write it as a product of two factors. Remember, this times this equals this. So the rest of your answer looks like x minus 4 times 5x plus 3. Okay, so then we are going to look at synthetic division. Now, I love synthetic division, and I think you will too as soon as you get used to the procedure. So the procedure that we're going to use are all these steps here. And it's basically like a shorthand division. So here are the important facts. You're still going to write your polynomial in standard form. So that is still exactly the same as what we had before with the long division, but you must include zeros for missing powers, and you had to do that in long division as well. So that first step is no different. But here's where it gets different. You are going to omit all variables and exponents. You're only going to use coefficients and constants. And then remember what we put outside the division bar? Well, we're not going to use the variable, so you're going to end up reversing the sign. So for instance, if I'm dividing by x minus 2, I want you to think of the fact that I'm really, the value for x, if I set it equal to 0, wouldn't x be 2? So when I divide with synthetic division, we're going to use 2, not negative 2, to divide by, because the root is actually 2, not negative 2. So that's why we're going to actually reverse, let's see, did it reverse the sign? And then, of course, as I did with long division, I add anyway, I don't ever subtract. So here we go. Let's look at a problem. So we are going to take this polynomial and divide it by x minus 7, and we're going to use synthetic division. So here's how we're going to set it up. We still have to look for any missing values. So I have x to the third, and I go to x to the first. So I'm missing x squared. So I'm going to start by putting that in there. So I'm missing x squared. So I have 0x squared. So let's check again. So I have 3, 2, 1, 0. So this is the only one I'm missing. So every time you set this up, you're going to do like a reverse division bar. So you're going to flip it. Then you're going to create a shelf, like elf on the shelf. You're going to create a shelf. And then this box right here is where your remainder is going to go. What I divide by, I'm dividing by this, is going to go over here, but we're omitting all the variables. So here's going to be 2 rows of numbers, basically a row here, and you're going to have a blank row here for right now. So I'm going to first start off by putting all the coefficients, 1, 0, negative 57, and 56, all along here. So let's start with that. So I have 1, my placeholder is 0, and then negative 57 and 56. The signs will be the death of you on this one. So then, remember when I put my divisor over here, I have to flip the sign, because think of this as if it's x minus 7 equals 0. The value of my root that I'm dividing by for x is really 7. So for this, I'm going to flip the sign and put a positive 7 here. Then the only other thing that's important is the very first step 100% of the time is to take this number, whatever it is, in this case it's a 1, and bring it down below the line. Then here's your process. I'm going to take the 7 and multiply it to the 1 and bring it up here. So 7, let me get a different color. Let's use this one. So 7 times 1 is 7, and then I'm going to add down. So I get 7, and then it starts all over again. So then I'm going to take 7 times 7 and put it here. So 7 times 7 is positive 49, and then you're going to add down. And so when I add down, I get a negative 8. And then 7 times negative 8 is negative 56, and I'm going to put that here. And then I'm going to add down, and I get 0. So again, here's the process. I took the coefficients only, I dropped all the variables and exponents, and I put them here. What I'm dividing by, I flip the sign and put it here. Now, here's a caveat, though. They gave me the linear factor x minus 7. What if they had just given me the root of 7? They only said divide by 7. If they don't give me the 0 as a factor, because this is a factor, then I don't change the sign. If they had just said divide by 7, I would have put a 7 here. But as soon as they put an x with it, x minus 7, I'm going to flip the sign. If this had been 2x minus 7, envision it being equal to 0, and 2x minus 7 would solve as 7 halves, so I would put a 7 halves here. So if you come across those, it might cause you some questions. All right, so we flipped the sign, immediately brought down the first number here below the line. Then you're just going to multiply. 7 times 1 is 7. It goes above the line. Add down. I get 7. 7 times 7 is 49. Add down. I get negative 8. 7 times negative 8 is negative 56. Add down. I got 0. So this right here is your remainder. And this right here is your quotient, your answer. So in long division, this would be what would be above the division bar, and this would be that remainder at the end. So this is missing the variables. So here's how you put your variables in. Since I started with an x cubed, 100% of the time this is going to be 1 power less. So in this case, an x squared. So put that in. So I get an x squared. The 7 is positive, so I have a plus 7x, and then minus my 8. So they want to know what's the quotient and remainder. So that right there, this is your quotient, and then this is your remainder. That's it. All right, so let's look at another problem. This time we're going to solve a word problem, and it says to use synthetic division. I prefer synthetic division. It's usually quicker. So let's go ahead and try it here. So it says, if the polynomial, here's your polynomial, am I missing anything? 3, 2, 1, 0, nope. Expresses the volume, so it's important that I highlight things that mean something. So the volume of a box. As soon as I hear volume of a box, I'm thinking, what is volume of a box? The formula for volume of a box is length times width times height. And so they give you the width, which is x plus 1 inches, and they want to know what are the dimensions. So I need to know what's the length, what's the width, and what's the height. So I know that the volume, V, is all of this, and my width right here is x plus 1. So for right now, I actually have the problem. Let's see, here we go. So volume x cubed plus 6x squared plus, that's a squared, plus 11x plus 6, that's my volume, equals length. My width is x plus 1 times my height. So if I want to know what length and height are, I would divide by x plus 1. Divide by x plus 1. And then what would be left would be my length times height. So I'm going to erase that, but essentially I'm going to take the volume and divide it by the width. Because if I leave that there, I will run out of room. All right, so let's go ahead and use synthetic division. Elf on the shelf. So I'm going to switch my sign. So since I have a plus 1 here, I'm going to switch the sign, reverse the sign, and make it a minus 1. Then I'm going to put my coefficients in the first row. So the coefficient of the x cubed is 1, coefficient of the x squared is 6, and then of your x is 11, and then a 6. So this is a little long, but that's okay. And then my break is going to go here because if I have a remainder, it'll be here. So 100% of the time, I'm going to bring down this first number below the line. Okay, and then my multiplication is going to start. So I'm going to take negative 1 times 1 and put it up here on the line. So negative 1 times 1 is negative 1. And then add down, I get positive 5. And then negative 1 times positive 5 is negative 5. We'll go here. And then add down, and I get positive 6. And then negative 1 times 6 is negative 6. We'll go there. Whoops, negative 6. And then add down, I get 0 for my remainder. So we should have expected to get 0 for a remainder, because if this is one of the dimensions, it should divide evenly into here. So then I started with an x cubed, so this represents x squared. So I've got 1x squared, it's an x, plus 5x plus 6. So that means that I have to factor x squared plus 5x plus 6, because that represents my length times my height. So is that factorable? Are there factors of 6 that add to give you 5? Remember, we're adding factors of 6. So you can't use 1 and 6 because those subtract to give you 5. But 2 and 3 add to give you 5, and they would both be positive. So what are the dimensions of the box? Therefore, the dimensions are x plus 1, that's the original dimension for what they gave us, x plus 2, and x plus 3. Then we can use synthetic division. You can also use long division, but again, I prefer synthetic division because it's so much quicker to evaluate a polynomial. Why would I want to do that? So basically, I want to know what is the value of 4 when I plug it in for any x here. Well, can I put that in my calculator? Sure, but what if you don't have a calculator handy? What if, so imagine the work you would have to do this. We want to know what is the value, of the function when I plug in 4. All right, so I would have to put in a negative 4 here, 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 and here. Well, if I have a calculator, that's not a big deal. I can just put this in my calculator exactly as I see it. But if I don't have a calculator, to take 4 to the 5th, negative 4 to the 5th power, multiply that out, then take negative 4 to the 4th power, multiply that out, multiply it by the 3, the negative 3, take negative 4 to the 3rd power, multiply that to negative 28, add all these together, add a negative 20, well, fortunately, negative 20 and positive 20 cancel. I mean, that's a lot of math. Look what happens with synthetic division. And by the way, if I did put this in the calculator, P of negative 4 is equal to 0. So let's see what synthetic division gives us. So I'm going to make my synthetic division. Am I missing any terms? 5, 4, 3. I am missing my x squared term. So I need to add a 0x squared here. And then 1 and 0. So my coefficients are 1, negative 3, negative 28. I'm putting in 0 as a placeholder. That's a positive 5, right? Yep, positive 5 and a 20. So then my remainder is going to go here, and my elf on the shelf is going to go there. So remember, this time I was not given this value as a linear factor. I'm just given a number, so I'm not going to reverse the sign when I put negative 4 in here. So I'm going to use the same value, negative 4. I don't reverse the sign. But look how easy the math is. I'm not even going to use a calculator. So first thing I'm going to do is drop down the 1. 4 times 1 is negative 4. Let me get a better color. Okay, so 4 times 1 is negative 4. add down, I get negative 7. 4 times negative 7 is positive 28. Add down, and I get 0. Negative 4 times 0 is 0. Add down, I get 0. Negative 4 times 0 is 0. Add down, I get 5. Negative 4 times 5 is negative 20. Add down, and I get 0. And in fact, I'm going to erase that because I want a different color because I want it to match. So 0. So look at the fact that this and this match. I was able to evaluate the value of this polynomial when x is negative 4 simply by using the remainder theorem, and whatever my remainder is the value when I plug in negative 4. So the math is so much easier when I do that. I didn't need to use a calculator. Well, I'm always going to have a calculator. Maybe you won't. So here's a time when you can actually use it. All right, last one. You were to determine if x minus 3 is a factor of this. So go ahead and pause the video, look for any missing terms, put that in, use synthetic division, and then restart the video. Okay, so I am missing terms. So I've got my x to the 4th, which is a 1, but I'm missing the, so let me use red for this. I'm missing the x cubed, the x squared, and the x. And then finally I have a negative 81. Here's where my remainder is going to go on my elf on the shelf. This time they've given me a linear factor, so I am reversing the sign and putting in a positive 3. And then I'm dropping down this 1, and I'm multiplying 3 times 1. Whoops, 3 times 1 is 3. Add down, I get 3. Then 3 times 3 is 9. Add down, I get 9. 3 times 9 is 27. Add down, I get 27. And then 3 times 27 is 81. Add down, I get 0. So because my remainder is 0, therefore I can conclude, yes, x minus 3 is a factor. Then they just said determine if it is. So you don't actually have to then use it to factor the rest of this, but you could, but they didn't ask for that. So as far as I'm concerned, that's as far as your answer has to go. So do pay attention to what the directions are asking you to do. Don't go too far with your answers, but then make sure that you go far enough. All right, if you have any questions, don't hesitate to ask.